Okay, now, same thing except making it just a little more involved. We're going to express ax squared plus a multiple of x plus a number as a multiple of a perfect square plus or minus some number. Okay? So, first thing we're going to do is, well, we're going to do this example. First thing we're going to do with this example is we're going to complete the square on the x squared and x term. There's a complication. We no longer have a 1 in front of the x squared. Okay, so first of all, we complete the square of 2x squared plus 4x. Okay? We can't just take half of this square and add it to the end. We're not going to get a perfect square if we do that. What we do is factor out the coefficient of x squared. So we get 2 times the quantity x squared plus 2x. Okay? Then complete the square on the monic polynomial, the expression with a 1 in front of x squared. That's what we mean by monic. Just using what we already know. Okay? And then, trying to figure out how to get this on the board here. Complete the square on x squared plus 2x, okay? Well, we're going to have to add a 1, right? So x squared plus 2x plus 1 is x plus 1 squared. So that x squared plus 2x is quantity x plus 1 squared minus 1. Okay, well now we can take that back here. Two times the quantity x squared plus 2x is then 2 times quantity x plus 1 squared minus 1. Careful, I'll do what I almost did. Okay, which is 2 then, well, distributive law. So 2 times this equals this. Now, of course, that's what we have here. So 2x squared plus 4x is 2 times the quantity x plus 1 squared minus 2. Thus, 2x squared plus 4x plus 9 equals 2 times the quantity x plus 1 squared minus 2 plus 9, which equals 2 times the quantity x plus 1 squared plus 7. And there it is, a multiple of a perfect square plus a number. The form is a times x plus h squared plus k. Okay, times x minus h squared plus k. So that this can apply to the graphing of a quadratic function. And that's where we're going to go next. But let's make sure we understand what we've done. We've isolated the part with the x's. We've factored out the 2 so that we have a monic expression in here. We take that monic expression, we complete the square on that monic expression, and we get this, so that the monic expression, the x squared plus 2x, is equal to the perfect square minus 1. So that 2 times x squared plus 2x is, well, 2 times that quantity, which equals this. And of course, if we multiply through by 2, we get this. And the reason I did that, of course, is that this matches this. So that now I can write this expression, replacing this with this here, and then just do a simple addition, and we've got this. Now, that's a lot of steps, and if you try to do it blindly, step by step, you might not totally understand it, so you have an alternative. But if you can do it this way, and I'm going to ask you to do it this way for homework, just so hopefully it'll seep in. But we could also write it this way. Okay, so I've got 2x squared, kind of glitch on the board there, isn't it? Plus 4x plus 9. Okay, well, what I do is I factor the 2 out here, and just on the x terms, and there I have that. And then that equals 2 times, well, x squared plus 2x. If you add 1, you get x plus 1 quantity squared. That's going to be a perfect square. And of course, I'd better subtract 1, so that this is the same as this. So now I take the x squared plus 2x plus 1 and write it as x plus 1 squared. I've still got my minus 1 here. And now I just use the distributive law. There I have this. Okay. Distributing 2 times negative 1. And I've got negative 2 plus 9. And I've got my result. Okay, so what I did here breaks it apart logically. This is also logical. This is broken into about 3 steps. This is done in 1, 2, 3, 4, 5 steps of algebraic manipulation. This is the process, and you can do this now with any expression of this form. Doesn't matter. Now sometimes you end up with fractions, and that's going to be a cause for great joy. But the process itself is something that with practice you should have no trouble with. So I'm going to give you plenty of opportunity to practice on this. I'm going to probably have you do more problems here of this type than I have on previous problems with completing the square, because this is where it comes together, and this is the most complicated procedure you're going to run into on completing the square. It doesn't get any more complicated than this. You want to nail this. And then I mentioned that this is applicable to graphing quadratic functions, because of course this puts it in the form where you can see your vertical stretch, your horizontal shift, your vertical shift.